I would like to start out by saying, yes, I am addicted to West Africa. I have been living there with my family for 9 years, but more than that, I even recently, through all these difficult past years, was intrigued by the hospitality, by the courage, by the loving embracement that our African partners always show towards me, towards PhD students, towards my colleagues. And I must say that even if I go to Niger, and I have recently been there and been to the Sahara under very difficult conditions, I always felt safe. And this is only due to the hospitality and the commitment that Africans have themselves towards their continent. Having said this, when I report today, I report the work that, of course, our PhD scholars have done, not my own work. Although I may put some perspective of my part onto what the PhD students so far, together with postdocs, have elaborated, and towards also colleagues from the partner institutions have contributed. The Declare project is based in two countries, basically in Ghana and in Benin, but we have also links through our African Excellence Center Pro-Ruva to Niger and to Mali, basically through the connections that are built in the project in between projects. So it's mainly the University for Development Studies, UDS in Ghana, and University of Parakou that contribute together with Wascal as the local basis. And then we have the German universities that you see here listed, all linked together in a project region of the subhumid savanna region of Ghana and Benin at an annual rainfall of about 800 and 1200 millimeters. You see to the right our main project areas. So the classical subhumid savanna zone. We may also stretch out to the project that is currently working in Togo to connect the ecoregion, but that's still a dream. That's something that is difficult due to the border crossings that on the land connection always go through Togo, but entail some particular administrative difficulties. What do we do? Well, we have 6 work packages. I don't want to go through all the detail, but one of the key results is the decision support system that I will be talking about in a moment, that is here marked in red to the lower right of this graph. We basically try to link land tenure system and land security to issues of climate change and the impacts that the current major transformation of the West African cropping systems and land use systems are having on the testing of sustainable land management practices. And we also try to implement a digital climate service solution for decision making. One of the major challenges in West Africa is actually the privatization of the commons. We all have heard about the tragedy of the commons, and we have learned that local populations have an amazing possibility to deal with the tragedy so that it doesn't become a tragedy, but rather becomes a land use that is, in many cases, much more sustainable than predicted in the 1970s after the 2 Sahelian droughts. We have also seen that even under the current political turmoils, under the distrust that is starting in particular to increase among the pastoral communities and between the pastoralists and the land users, the sedentary land users, that was always an issue, but now it has become even more so. We see that within that context, farmers increasingly try to buy land. And once they have bought land, then they can put a fence around. And this means that the pastoral corridors, the movement of the animals is severely restricted. And the conflicts that are there for hundreds of years now become even more flagrant because the landowner can simply say, here is a border that you cannot pass, even if your animals don't eat my crops. And this picture shows that in the middle, the classical village in northern Benin. And to the sides, you see not only those maize fields, but you see to the right and also to the upper part, cashew and mango plantations that are increasingly entering and documenting that privatization. Here you also see it, all these forests that are there, they are agroforestry systems, which we certainly welcome for sustainability reasons, but at the same time, they document this private possession and also exclusive possession of land. I have told you initially that we try to develop as an ultimate applicable goal of the Declarary project a decision support system for sustainable land use, DSSLU, if you want to call it. And it allows to link different scales on land use to a coherent mode of understanding what's going on and what will happen if you make changes, particular bottleneck changes in the system. So what we need to elaborate in the Declarary project are the data that are feeding into that decision support system. And then we try with the final users, which are the stakeholders in the land use systems, to verify that we have correctly measured what the system predicts to happen. So we are working on issues of fertilizer use, on land security, on tenure, but also on effects of climate change on crop cultivars. As you see here to the right, certainly also on irrigation and post-harvest losses. These are all topics that somehow we need to address. Of course, we cannot do that completely. We cannot do it everywhere, but we try, directed by the needs of the models, to use the data that we are generating to feed that into the model. We have, like you all have in your projects, milestones, and I don't want to go into the details of this, just that you know that we are output-oriented, which means, of course, our PhD students in Declaré need to do their thesis, and there may be delays due to personal reasons or to climatic problems or to whatsoever. We still need to take those milestones serious, and you see that already at the quite early stage in year one, we have we had an agreement that everybody embraces the decision support system structure, and we discussed the innovations that we would like to test in that context. And then this basically goes through until package 5, package 6 that come more at year 3 and year 4 into the play to verify that we are on track. Let me provide you with some first results. And once more, thank you very much for the PhD scholars that have contributed to them. I have not mentioned always the names because sometimes that was too interdisciplinary. I should have shown all of them. And sometimes also the PhD scholars were modest enough to not even mention their name. And therefore, you will see it wherever appropriate, wherever I have the data. Otherwise, the names are in the data, so to speak. But as I was thinking in the beginning, the entire group, you all are included, even if you don't find your names listed. So let's first have a quick look at agroforestry, crop production, and nutrient use. And one of the key innovations that we are testing here in the context of the systems is actually microdosing. What is microdosing? It's technology that has been developed in the 1990s on the premises of ICRISAT by scientists from University of Hohenheim as part of a PhD thesis. And it was at that time my work to verify the technology and to then make it ready for farmers. And it consists in applying 1.5 grams of NPK per planting hole. So this is 3-4 granules of the fertilizer. And it can be used for all cereals, but recently it has been also tested under vegetable systems. However, all the wealth of data that has been collected on tens of thousands of farmers that are actually using it since the 1990s, it has substantially boosted yields, were done in monocrop system, or let's say in very much cereal dominated system. What has not been checked is how the microdosing works in agroforestry based system, where of course you have a gradient of fertility from the stem to the outsides of the tree, and that's what you will see here on the left side. This round dashed area is the area where you have the tree. I show it here with my cursor. I hope that can be seen. And we have a number of treatments here. Control stands for unfertilized farmer managed, and then we have the microdosing experiment, and this is repeating itself on distance from the tree. So basically have a zoning effect, 3 zones, 3 meters from the tree, 10 meters from the tree, and 20 meters from the tree. This is work that is mainly done by Amisu in Ghana and Sharonim, and they will certainly be happy to give more details in the discussion later. So one factor is treatment, and the other one basically is the zoning. And we try to see what is happening with yields, with grain yields, and certainly measure all the needed parameters for that. Now, the first data show that the grain yield close to the trunk is lower. That has to do certainly with the water competition and with the extreme shade that very close to the tree is. Sometimes also you have termites there, so there's termite damage. But as soon as you move away from the tree, you have an increase that has to do certainly with the effect of the fertility effect of the trees. They are normally not acacia albida trees. They are maybe cashew trees, so there is no effect directly from leaves that are falling, only partly. There's also birds that are nesting on the trees and have their droppings, or there are animals that are grazing under the tree and have their droppings. But we also see that the microdose plots yielded 30% higher than the average grain yields of the farmers. And this is substantial, particularly given the very small amount of fertilizer that is used, which corresponds to about 1/5 to 1/10 of what the government recommended rate is. What we also see is that through this increase in production, we have a decrease in the water availability, which means that the millets or the sorghum or the maize that you are growing under the tree certainly transpires. And with that, the microdosed plots have a lower water, particularly in the very deep horizons, than the unfertilized controls. Now, that, in my view, is a positive phenomenon, because less unused water means less leaching, means also less transport of nitrogen fluxes, mineralized nitrogen, into the lower soil horizons. What we also see, this is not working here, yes, that food technology plays a major role to limit post-harvest losses. And this has particular importance when you look at the production of cheese, wagashi cheese, which is typically done by agropastoralists to have a good use for their milk. And the group here was already successful in publishing a review paper in Discover Food, a peer-reviewed international journal. So congratulations to the PhD scholars, and a good example for all of us. But also there was a considerable variability in the uses of milk by these pastoralists, both as daily food under gari and tuo safi, which is a porridge that is made, but also in other forms. And we see also that the milk yield per cow is very low. This is between 0.3 to 2 liters. That has to do both with the heat in the dry season, but also the fodder basis, of course, that is an issue. And in the dry season, therefore, the milk and wagashi production is really not contributing a major lot to the income. This changes then as you move to the into the rainy season. Diseases are a major issue also that is challenging the dairy production, in particular ticks are an issue, but also other diseases, zoonotic diseases partly that risk to humans. And there is issues of hygienic milk processing and wagashi production that certainly would harm the international, or let's say the transboundary marketing of that cheese if everybody was aware of those practices and could improve them, probably also for the middle class markets, not only in Benin and Ghana, but also in big places, big markets such as Nigeria, would have a greater future even. Here you see some of the products that come out of the wagashi. We also learned that it is mostly leaves of Caianus procera that are coagulants in the wagashi production. And the sales only is, of course, one part that you have to look at, because many people also use it for their own consumption. Shelf life of the wagashi uncooled is only about 1 to 3 days, which is, of course, a major hindrance to marketing to the big cities, even at the national level. The lemon juice has been also used as a coagulant. However, it's not as good as those tree-based coagulants. And there was also some problems on the quality. Not only the coagulation itself, but also the quality is an issue. Training of herdsmen and women goes along with the data assessment, with the data collection on how much milk is produced, how much wagashi is produced, how the hygienic conditions are. So this going back and forth and swimming within the water, whereby the water are the herdsmen and herdswomen, is very important for Declaré. We don't want to work in an ivory tower where at the end the model predicts something and the reality is a different one. So we do plan also proper experiments on quality analysis that will start this summer. When we look at the animal production and the nutrition, and here again, thanks to Elisabeth at Fremont, what we learn is that basic work that they have done shows that the grass cover and the forbs cover really change during the rainy season and during the season, the dry season, and also as compared to the northern savanna to the southern savanna. So we do have the change over the year and also throughout the season. That is important, certainly, for the animal nutrition. Interesting also is the majority, regardless of the region of the animals kept, are cattle, which means that these cattle, as they are large ruminants, they need a lot of fodder, they need to move. And any regulation from the government that apparently seems to guarantee that there is fodder that is brought in, that is provided by fodder banks, or that is alfalfa that is even imported from neighboring countries, will not work for the large quantity of the cattle. So movement is a must. And therefore pastoral land use needs to continue despite of the legislative obstacles and despite also of the major security problem that exists when going from one country to the other, or even within the country. Let's just think about northern Benin, where already there is an issue, not only talking about Boko Haram in Nigeria. Pasture species in the study areas of northern Benin are characterized by dominant species, and they are listed here. And important is that not only the herders know those species, but also the agriculturalists know them. And there is an agreement that these species are not cut for charcoal production, but they play a major role in the ecosystem, and many of them have effects on the browsing of the animals and also on the quality of the herbage, because depending on the leaves that fall, we have different effects on the herbage growth. Research highlights in the social sciences are at the moment still elaborated. What we have had is a major household survey. Almost 3,000 households were interviewed in northern Ghana. And what becomes very clear is that land tenure, land use rights are a key issue to be understood. And any change in innovation will need to consider those. We understand that in Ghana there is 5 different types of land tenure systems that basically start from inheritance and go all the way to just walk in, passing by people. They go to the chief and apparently get land allocated, even though land is increasingly scarce, but the chief has no chance but giving some land, even if it's no real good land. And the political system is so stable that the large majority, 72% of the landholders, are not really worried to lose their land. This is different in Benin. There is a little bit more of that anxiety because the privatization has not yet advanced, and certainly in neighboring countries this is even more of an issue, and this land tenure security has also implications for the land care that the farmers and the herders are taking. I would like to close by shedding some light on the participatory land tenure mapping that allows to collect and collect also in terms of the distribution of where it's being applied, traditional knowledge about how farmers take care of the land, what they do with the animals, and how the interaction between happens. And we are continuously surprised by the innovative solutions such as forest production and mutual exchanges between farmers that allow them to cope with droughts, but also to respond to new market demands by the rising commercialization of the products as a consequence of the urbanization in both countries. Cash crops, I've already mentioned cashew is an important one, but also shea butter is an important one. Are an opportunity, but also pose a threat to household food security because they often replace the traditional food crops, or they don't leave labor for the food crops, and they lead to privatization, as we have seen, which is a threat then to the pastoral households. I should have a small note still on the crop modeling. We also do that in connection with climate influences. You should talk to the responsible PhD scholars on the precise state of where the crop modeling is. At the moment, we are still collecting input data, but the first really true modeling exercises are already running. Last, if you want scale, is then to not only model crop growth, but model agroforestry as part of the land use system. And this is being done with the aim to quantify the water demand as compared to a monocrop system, to a cereals only system. So it needs to be combined also with hydrological data. And this is what you see here, the combination of input data, classical input data, the agricultural effects, and then the water availability will together lead to that basis that allows then the decision support system to operate. Thank you very much for your patience. And if there's any questions, please let me know.